Hey everyone, and welcome. Today, we're diving into one of the most fundamental building blocks of Python, functions. We're going to frame them as little code machines that you can build yourself, and you'll see pretty quickly how these things can make your code so much cleaner, way more efficient, and honestly, just easier to deal with. So let's get building.
So let me ask you a question. Have you ever found yourself writing the exact same lines of code again and again and again? Yeah, we've all been there. It's a super common thing when you're starting out, but trust me, there is a much, much better way.
And that brings us right to our first section. Why even bother with functions in the first place? Before we jump into the how, I really want you to understand the why. So let's take a closer look at the problem with repetitive code.
Okay, so picture this. You need to print the same message in a few different spots in your script. Your first instinct, totally natural, is to just copy and paste it, right? You get something that looks like this. Seems simple enough. For now.
But what happens when your boss comes along and says, "Hey, can you change that exclamation point to a period?" Well, suddenly you're on a treasure hunt, trying to find and fix every single instance by hand. You can see how easy it would be to miss one, especially if this code was spread across multiple files. It's just a recipe for introducing bugs.
And this whole idea is so important that it actually has a name. It's a core concept in programming called the DRY principle. It stands for Don't Repeat Yourself. The whole goal is to avoid this kind of repetition by putting that logic in one central single place.
So, enough about the problem. Let's build the solution. In this next section, we are going to build your very first code machine by defining and then calling a really basic function.
The blueprint for any function in Python always starts with the keyword def, which is just short for define. After that, you give your function a unique name, and then you have a set of parentheses. And as you'll see in a minute, those parentheses are where we'll eventually put our inputs.
So it's really a simple two-step dance. Step 1, we define the function. We're basically teaching Python a new trick. We're saying, hey, whenever I say hello_func, I want you to give me back this string. Then, in step 2, we call the function. That's when we're actually telling Python, okay, do that trick now.
Now pay close attention to this one, because this trips up everybody when they're first starting out. If you print the function's name without the parentheses, Python just tells you what it is. It's a function object just sitting there in memory. To actually run the code inside and get the value back, you have to add the parentheses. That's the signal to execute it.
And here's where things get really cool. Because our function returns a string, we can treat the entire function call as if it is that string. That means we can do things like chain a string method, like .upper, directly onto the end of our function call. This is when functions start to feel like a real superpower.
All right, so our little machine works, but it's kind of a one-trick pony, right? It does the exact same thing every single time. Let's make it more flexible. In this section, we're going to learn how to give our machine some inputs using parameters and arguments.
Okay, let's get our vocabulary right, because it's important. A parameter is the placeholder variable you create inside the function's definition. Think of it as the labeled slot on the machine. An argument is the actual value that you pass into that slot when you call the function. It's the thing you actually drop in.
So what happens if you set up a slot, a parameter, but you forget to pass in a value for it? Well, Python won't just crash. It'll actually give you a pretty helpful type error that tells you exactly what went wrong. Here, it's saying, hey, you forgot to give me the greeting argument I was expecting.
So how do we make an input optional? It's actually really simple. We just give the parameter a default value right there in the function definition. So on the left, greeting is a required parameter. You have to provide an argument for it every time. But on the right, we've set name to equal you by default. Now it's optional. If you don't provide a name, it'll just use you. Okay, time to upgrade to the supercharged model. What if you don't know ahead of time how many inputs your machine is going to get? That's what this section is all about, the supercharged function that can handle an unknown number of inputs.
This is where these two magic syntaxes, args and kwargs, come into play. Args with 1 star lets you pass in as many positional arguments as you want, like math and art, and it scoops them all up into a tuple. Kwargs with 2 stars does the same thing for keyword arguments, collecting them into a dictionary. This gives your functions ultimate flexibility.
All right, let's put all of these pieces together. In our final section, we are going to build a full-on code factory using a real-world example taken straight out of Python's own standard library. This is the kind of stuff pros use every day.
So, inside our little factory, we have a few key components. We've got a list that holds some data, month, days, and then we have two separate functions, two little worker machines, one called isLeap and another called DaysInMonth. And they're designed to work together to solve a bigger problem.
So here's the job order for our factory. Figure out how many days were in February of 2017. Let's fire up our days_month function and see how it gets the job done.
Okay, let's trace the logic. First, our function gets the inputs 2017 and 2. Step 1, it checks if the month is valid. 2 is between 1 and 12, so check. Step 2, it asks two questions. Is the month February? Yes. And is the year a leap year? Well, to figure that out, it has to call our other function, isLeap, and pass it 2017. In step 3, the isLeap function does its job and returns false. So now, back in our main function, since one part of that AND check was false, the whole thing becomes false. So it skips ahead to step 5 and just returns whatever value is at index 2 of our month days list.
And the value at index 2 in our list is 28. Boom! Our little code factory processed the inputs, used its different machines, and gave us the correct answer.
And one last quick tip on best practices. As your functions get more complicated, you absolutely want to document what they do. In Python, we do this with something called a docstring. It's just a special comment right at the top of the function. It's a simple habit that will make your code so much easier for other people and for your future self to understand.
So let's just do a quick recap. The big takeaways here are: functions help keep your code dry. Don't repeat yourself. They act like little code machines that can return values. We use parameters to make those machines flexible and customizable. Args and double kwargs are your tools for handling all sorts of different inputs. And, as we saw, you can make your functions work together like a factory to solve really complex problems. And that leaves us with one final, really exciting thought. You now know how to build your own code machines from scratch. So the next logical question is, how do you import and use all the powerful, incredible machines that other programmers have already built and shared with the world? And that, my friends, opens up a whole new universe of possibilities.